Problems based on variable separable method. Previously I told you in the same session, one problem, general solution of the equation dy by dx is equal to x into 2 log x plus 1 whole divided by sin y plus y into cos y is first option y into sin y is equal to x square plus c. Second option y plus sin y is equal to x square plus log x plus c. And third option y is equal to sin y plus x square plus c. And fourth option y sin y is equal to x square log x plus c. మనం ఇంతకుముందు డిస్కస్ చేసామంటే వేరియబుల్ సెపరబుల్ కండిషన్. సో all the variables along x-axis write to alone dx and all the variables y alone to y write dy. So given problem is dy by dx is equals to x into 2 log x plus 1 whole divided by sin y plus y into cos y. Now mutually cross multiplying here, denominator all the terms containing y terms and here numerator is also dy. So sin y plus y into cos y into dy is equals to x into 2 log x plus 1 into dx. Now sin y into dy plus y into cos y into dy is equal to 2 into, can multiplying with x into log x into dx plus x into 1 x into dx. Variables are separable. Now can integrating both sides, integral of, just applying integral sign, sin y dy, sin y integration is minus cos y plus y into cos y into dy. Now can applying here integration by parts. In different integration, you know integration by parts, first function and second function based on Euler formulae. Euler means I stands for inverse trigonometric function, L is logarithmic function, A is algebraic function, T is a trigonometric function. So here y and cos y, cos is the trigonometric function, y is an algebraic function. A means algebraic, T the trigonometric. So A tarvata T was, A means first function, algebraic function is the first function and T is the trigonometric function, second function. First function into integral of second function, cos y integration sin y minus integral of derivative of first function, y derivative is 1 into cos y integration sin y into dy is equals to first function into integral of second function minus integral of derivative of first function into integral of second function sin y into dy is equal to 2 into, here also same by parts formula, first function, which is the first function here, I inverse ledu, logarithmic function undi. So I tarvata inverse tarvata logarithmic vastundi, L logarithmic tarvata algebraic vastundi. So x anedi algebraic function, L tarvata A vastundi kabatti L is the first function, logarithmic function log x is the first function and x is the second function. So first function into log x into integral of second function x integration x square by 2 minus integral of derivative of first function log x derivative 1 by x integral of second function x square by 2, xx will go into dx, plus integral x dx is x square by 2, plus c here. Minus cos y plus y sin y, again minus integral of sin y dy minus cos y, minus of minus plus cos y is equal to, now we can multiplying with 2 into log x into x square by 2, 2 into x square by 2 into log x, 2 will go, plus y minus cos y plus cos y will go. Next plus into minus, minus of 2 into integral of 1 by 2 into integral of x dx plus x square by 2 plus x square by 2 plus c. 2 will go, that is left side is y sin y is equals to x square into log x minus integral x dx is x square by 2 and plus x square by 2 plus c. Here both negative, positive will go. Therefore, y into sin y is equal to x square log x plus c. Y sin y equal to x square log x plus c. Can write in options form, y into sin y is equals to x square log x nothing but ln x plus c, which is the solution of the given problem. The general solution dy by dx is equal to x cos x plus sin x is first option xy plus sin x plus c. Second option y is equal to x cos x plus c. Third option y is equal to x plus sin x plus c. And fourth option y is equal to x sin x plus c. Solution given dy by dx is equals to x cos x plus sin x. Now variables are separable. Here denominator is 1. dy is equals to x cos x plus sin x into dx. That is equal to x into cos x dx plus sin x dx. dy is equal. Now integrating both sides. Integral dy is y is equal to x cos x. Again applying integration by parts here. ILATE, A algebraic T trigonometric functions. First function is here x. Second function is trigonometric function cos x. First function into integral of cos x is sin x minus integral of derivative of first function x derivative is 1 into integral of cos x is sin x into dx plus integral of sin x dx is minus cos x plus c, that is equals to x sin x minus integral of sin x dx is plus minus cos x before negative sign plus cos x, here minus cos x plus c, and minus cos x plus cos x will go. Y is equal to that, therefore that implies y is equal to x sin x plus c, which is the solution of the given problem. Next problem, the solution of x square plus y square into dy by dx is equal to 4 is first option x square plus y square is equal to 12x plus c. Second option x square plus y square is equal to 3x plus c. Third option, x cube plus y cube is equal to 3x plus c. Fourth option, x cube plus y cube is equal to 12x plus c. Solution, x square plus y square into dy by dx is equal to 4. Y square into dy by dx is equal to 4 minus x square. Now y square into dy is equal to 4 minus x square into dx. Now variables are separate here. Now integrating on both sides, integral of y square into dy is equal to integral of 4 minus x square into dx. Integral of y square into dy is equal to integral of 4 into dx, 4 constant taking outside dx, minus integral of x square dx, integral of x square dx. Now y square integration y cube by 3 is equal to 4 into integral dx is x minus x square integration x cube by 3 plus c by 3. Integral constant, you can take it as a c by 3. It is a totally constant. Here y cube by 3 is equals to 12x minus x cube by 3 plus c by 3. So totally LCM is left side, right side is 3, left side also 3 here. Y cube is equals to 12x minus x cube plus c. Now can write it as minus x cube taking to left side plus x cube, already plus positive y cube here is equal to 12x plus c, which is the required solution of the given problem. So fourth one is the correct solution of the given problem. Next problem, the curve whose subtangent is twice the abscissa of the point of contact and passing through 1, 2 is, first option y square is equal to 4x, second option y square is equal to 2x plus 2, third option x square is equal to 4y minus 3, fourth option x square is equal to minus 4y. Solution, the curve whose subtangent is twice the abscissa of the point of contact passing through this point 1, 2 given subtangent is equal to twice the abscissa, 2 times of abscissa. Subtangent of the curve is y by m is equal to 2 into abscissa of that point of contact is x. X coordinate is nothing but abscissa, y coordinate is nothing but ordinate, where m is the slope of the tangent. Slope of the tangent is dy by dx, that's why y by dy by dx, m nothing but slope dy by dx is equal to 2x. Therefore y is equal to 2x into dy by dx. Now variables separable method, dx by x, and this dx taking to left side it goes to numerator, and x taking to left side it is a multiple goes to denominator. Dx by x is equal to 2 times of dy by, and this y taking to right side it goes to denominator dy by y. Variables are separable. Now integrating on both sides, integral of dx by x is equal to 2 into integral of dy by y. Integral dx by x is a log x is equal to 2e into integral dy by y is log y plus log c. Integral constant is taken as log c. Log c, generally integral constant taking for our convenience to get the solution of the given problem. So log 2 log y can be written as log y square, log x to the power of n into log x plus log c. Log a plus log b, again we can write it as log of a into b, c y square. Here a is c, b is y square. Log a into b can write it as log a plus log b, log x. Therefore x is equal to c y square, which is a, and this passes through the point 1 comma 2. 1 comma 2, this is x coordinate and this is y coordinate. Substitute 1 comma 2 in the above. So x is equal to 1 is equal to c into y square. Y square is 2 square 4. Therefore c is equal to 1 by 4. C is equal to 1 by 4. Therefore y square is equals to, the equation becomes x is equal to c value is 1 by 4 into y square. Substitute c value in this equation. X is equal to, c value is 1 by 4 into y square. Therefore y square is equal to 4x, which is the required solution of the given problem. So y square equal 4x is, first option is the correct option. 2xy into dy by dx is equal to 1 plus y square is, first option 1 minus y square is equal to cx, second option 1 plus y square is equal to cx, third option 1 minus x square is equal to cy, and fourth option 1 plus x square is equal to cy. Solution: given 2xy into dy by dx is equal to 1 plus y square. Here 2xy, 2 into y into dy, same variables, 2y into dy. Left side having a y square variable, y variable taking to left side, right side this value taking to left side, and it goes to denominator 1 plus y square is equal to, here denominator dx taking to right side, it goes to numerator dx, and here x is there, and it taking to right side, it goes to denominator dx by x. Now variables are separable here. Integrating on both sides, 2 constant into 2y into dy by 1 plus y square integration is equal to integral of dx by x. You think about this numerator 2y into dy by 1 plus y square. Here denominator is 1 plus y square. If you are differentiating the denominator, you will get the numerator. F dash x by f of x into dx. So f dash y by f of y into dy is log f of y. That is log 1 plus y square. 1 plus y square is equal to integral dx by x is log x plus log c. Integral constant is log c. That is equals 1 plus y square. Log a plus log b, you can write it as log cx. Log 1 plus y square. Therefore 1 plus y square is equal to cx, which is the required solution of the given problem. So second one is the solution of the given problem. 1 plus y square equal to cx. Next question, the general solution of y into dy by dx is equal to x into e power x square minus y square is, first option e power x square plus e power y square is equal to c. Second option e power x square into e power y square is equal to c. And third option e power x square minus y square is equal to c. And fourth option e power y square is equal to e power x square plus c. Given equation y into dy by dx is equals to x into e power x square minus y square. Y into dy by dx is equals to x into e power x square into e power by e power y square. And this term taking to numerator, it is a negative sign, power. E power x square into e power minus y square. Actually this meaning e power x square into e power minus y square. Bases are equal, power should be added. That's why it can be written as 1 by e power y square. Now separating the variables, y into e power y square into dy is equal to x into e power x square into dx. E power y square is equals to t. Now e power y square, derivative of e power y square into derivative of y square is 2y into dy is equal to dt. So e power y square here, y is here and dy is there. So we have to require the 2. Now we can multiplying both sides for this equation 2. Multiplying both sides with 2, integral of 2y into e power y square into dy is equals to dt. Integral dt is equals to. Similarly, and this can be written as put e power x square is equals to put e power x square is equal to some z. Derivative of e power x square into x square derivative 2x is into dx is equal to dz. Therefore, the above integral becomes integral of dt is equal to integral of dz. Left side e power y square is taken as t and e power x square is here taken as z. 2y into e power y square into dy equal to dt. So instead of this total function dt is equal to 2x into e power x square into dx, it is equals to dz. Integral dt is t is equal to z plus c. Now substitute again, t value is here, e power y square is equals to z is nothing but e power x square plus c, which is the required solution of the given problem. Next, if the given differential equation of the form dy by dx is equal to f of ax plus b, if the given differential equation is of the form dy by dx is equal to f of ax plus b, then put ax plus b is equal to t. If the given differential equation is in the form of f of dy by dx is equals to f of ax plus by, then put ax plus by is equals to t. Next problem, general solution of the equation, general solution of the equation sin inverse dy by dx is equal to x plus y is, first option, tan of x plus y minus secant of x plus y is equal to x plus c. Second option, tan of x plus y by 2 is equal to c. Third option, tan of x plus y minus secant of x plus y is equal to c. Fourth option, tan of x plus y is equal to x plus c. Given equation is sin inverse of dy by dx is equal to x plus y. Therefore, dy by dx is equal to sin of x plus y. Just previously I told you, if the given differential equation dy by dx is equal to f of ax plus by, then put ax plus by is equal to some another variable t That's why put x plus y is equal to t. Now differentiating with respect to x derivative 1 plus y derivative dy by dx is equal to dt by dx. Therefore, dy by dx is equal to dt by dx minus 1. So, instead of dy by dx, you have to write dt by dx minus 1. dt by dx minus 1 is equal to sin t. This value is considered as t, sin t. Therefore, dt by dx is equal to 1 plus sin t. Now, separating the variables, 1 by 1 plus sin t. This term taking to left side, it goes to denominator into dt is equal to dx. Now integrating on both sides, after variables are separable, now integrating on both sides 1 by 1 plus sin t. Now rationalizing the denominator, 1 minus sin t by 1 minus sin t into dt is equal to integral of dx. And numerator is 1 minus sin t into dt by denominator a plus b into a minus b, a square minus b square, 1 minus sin square t is equal to integral of dx. That is equals integral of 1 minus sin t by 1 minus sin square t is equal to cos square t dt is equal to integral of dx. Here a minus b upon c, you can write it as a upon c minus b upon c, integral of 1 by cos square t into dt minus integral of sin t by cos square t. That cos square t can be split into 2 times, cos t into 1 by cos t dt is equal to integral of dx. 1 by cos square t nothing but secant square t dt minus integral of sin t by cos t is tan t into 1 by cos t is secant t into dt is equal to integral of dx. You know integral secant square t dt tan t minus integral of tan t secant t is equal to integral dx is x plus c. Now substitute t value finally here t is equal to x plus y, tan of t value is x plus y minus secant of t value is x plus y is equal to x plus c, which is the required solution of the given problem. So first one is the solution of the first option is the solution of the given problem. Next topic, homogeneous function. Homogeneous function means homogeneous function. First we define this homogeneous function. A function f of x comma y is said to be homogeneous function if f of kx comma ky is equal to k power n into f of x comma y, where n is the degree of the function. A function f of x comma y is said to be homogeneous function if f of kx comma ky equal to k power n into f of x comma y, where n is the degree of the function. Take one example. Small example, x cube plus y cube is equals to x cube plus y cube by x plus y. This is the given function. This function is said to be homogeneous function if it satisfying the above condition. F of kx comma ky is equal to, so replace k by here x by kx, y by ky. Substitute these values in this function. Kx whole cube. Kx whole cube means k cube into x cube. We can take k cube common, x cube, plus ky whole cube, k cube into y cube. Already here k cube common, plus y cube whole divided by x, kx plus ky. We can take again k common, x plus y. K will go one time. That is equal k square into x cube plus y cube whole divided by x plus y. That is equal k square into this value is equals to what? The given function is f of x comma y. F of x comma y. F of kx comma ky is equals to. So f of kx comma, see this definition, f of kx comma ky is equal to k power n. Here n is the degree, here 2 is the degree of this function, into f of x comma y. So this function at this, which is called as a homogeneous function. Next, homogeneous differential equation. Homogeneous function, homogeneous differential equation. Homogeneous differential equation, DE, differential equation. If the given differential equation of the form, given differential equation of the form dy by dx is equals to f of x comma y by g of x comma y, where this is called as a homogeneous differential equation. Once again, I will repeat this definition. If the given differential equation is of the form dy by dx is equal to f of x comma y by g of x comma y, where f of x comma y, and g of x comma y are the homogeneous functions of same degree, homogeneous functions of x and y, functions of small x and small y of the same degree, is called homogeneous differential equation. Homogeneous differential equation. Next, working rule. Working rule. To convert the given differential equation is of the form dy by dx is equal to x power n into g of y by x. Convert the given differential equation of the form dy by dx is equal to x power into g of y by x, and put y by x is equal to v, y is equal to vx. Problem: the solution of x square plus y square into dx is equal to 2xy into dy is, first option, c into x square minus y square is equal to x. Second option, c into x square plus y square is equal to x. And the third option, c into x square minus y square is equal to y. Fourth option, c into x square plus y square is equals to y. Solution, given x square plus y square into dx is equal to 2xy into dy. Now this can be written as dy by dx is equal to dy by dx is equal to x square plus y square by 2xy. dy upon dx is equal to x square plus y square by 2xy. So which is a homogeneous function because of f of x comma y, and numerator is f of x comma y, denominator is g of x comma y. Both f of x comma y and g of x comma y of same degree. So x square degree means 2, y square also degree 2. Denominator x power 1, y power 1. It is a monomial. Sum of the exponents is 2. So it is a homogeneous equation. Convert this homogeneous equation into either dy by dx is equal to x power n into g of y by x. That's why you can take numerator x square common, 1 plus y by x whole square. If you can multiply x square into 1, x square plus x square into y by x whole square means y square by x square will go, you will get the same numerator. By denominator you can take x into 2y, xx will go. Therefore dy by dx is equals to 1 plus y by x whole square whole divided by, this numerator x can be written as 2y by x, 2 into y by x. If you మీరు కనుక ఈ సింప్లిఫై చేస్తే x goes to numerator, మళ్ళీ x ఇది న్యూమరేటర్కే పాస్ అవుతుంది. కాబట్టి ఇక్కడ ఉన్న xని డినామినేటర్లో రాసుకున్నాం. Then put y by x is equal to v. Put y is equal to vx. That implies y by x is equal to v. Differentiating this function with respect to x, dy by dx is equal to vx. UV rule apply here. First function v into derivative of x 1 plus x into derivative of v with respect to x dv by dx. Therefore dy by dx is equals to v plus x into dv by dx. Now the above equation will become, instead of dy by dx, just replace this value, v plus x into dv by dx is equal to 1 plus y by x is equals to v square by 2 into y by x is v. Now variables separable, x into dv by dx is equals to 1 plus v square by 2v minus v, that is equal to 1 plus v square minus v into 2v square whole divided by 2v. Therefore x into dv by dx is equals to 1 my plus v square minus 2v square minus v square by 2v. Now variables are separated here. Two v into dv by 1 minus v square is equal to dx by x. So here variables are separated and then integrating, integral of 2v into dv by 1 minus v square is equal to integral of dx by x. Integral of 2v into dv by 1 minus v square, how can you write it, which is in the form of a square minus b square? You can write it as a plus b into a minus b. That's why 1 plus v into 1 minus v is equal to integral of dx by x. Here introducing partial fractions. Partial fractions 1 plus v, 1 minus v. These two are non-repeated linear factors. That's why you can write it as, find this value 2v by 1 plus v rough work. This is a rough work. 2v by 1 plus v into 1 minus v is equal to, we can write it as a by 1 plus v plus b by 1 minus v. In partial fractions, you know, it is a denominator non-repeated linear factors. We can write it as a by first non-repeated linear factor, b by 1 minus v. So here left side LCM is 1 plus v into 1 minus v. A into 1 minus v plus b into 1 plus v. 2v by 1 plus v into 1 minus v. So the denominator will go 2v is equal to a into 1 minus v plus b into 1 plus v. Finding a and b values. Put v is equal to 1, this term will become 0. If v is equals to 1, that implies left side value is 2 into 1, 2 is equal to, it is 0 plus 1 plus 1, 2b. Therefore, that implies b is equal to 1. B value is 1. If v equal to minus 1, if v is equal to minus 1, left side 2 into minus 1, minus 2 is equal to, here a 1 minus of minus plus 1, so 2a plus 1 minus 1, 0. That implies a is equal to minus 1. This total part is only rough work for using partial fractions. That is equals to integral of this value is equals to, a value is minus 1 by 1 plus v plus b value is 1 by 1 minus v into dv is equal to integral of dx by x. Integral of minus 1 by 1 plus v into dv plus integral of 1 by 1 minus v into dv is equal to integral of dx by x. This is a negative and this is positive. For our convenience, we have to write this is first one and this is second one. It's continuation part. Integral of 1 by 1 minus v into dv minus integral of 1 by 1 plus v into dv is equal to integral of dx by x. This is a log of 1 minus v by minus 1. Formula integral of 1 by ax plus b. Here v is a variable. Its coefficient is minus 1. Ax plus b by integral 1 by ax plus b into dx is log of ax plus b by a. Means x coefficient in that formula a. Here v is the variable. Its coefficient is minus 1. Minus integral of, that is log of 1 plus v by v coefficient is positive 1. No need to write. That is equals to integral of dx by x is log x plus log c. Integral constant is log c. So minus log of 1 minus v minus log of 1 plus v is equal to log x plus log c. Log a plus log b, you can write it as log ab. In left side, you can take a negative sign common. Log 1 minus v plus log 1 plus v. So log a plus log b, log of a into b. Continuation part minus log a plus log b, log of a into b, log of a into b, 1 minus v into 1 plus v, 1 minus v square, a plus b into a minus b, a square minus b square is equal to log cx, log of cx. So log of 1 minus v square plus log cx is equal to 0. log a plus log b, you can write it as log of a into b, 1 minus v square into cx is equal to 0. Therefore, 1 minus v square into cx is equal to e power 0, that is equals to 1. E power 0, here base e power 0, 1. Substitute v value, y is equal to vx, v is equal to y by x, 1 minus y by x whole square into cx is equal to 1, 1 minus y square by x square into cx is equals to 1, x square minus y square by x square into cx is equals to 1, x will go. Therefore, c into x square minus y square is equal to x, which is the solution of the given equation. C into x square minus y square equal to x. If 1 plus e power x by y into dx plus e power x by y into 1 minus x by y into dy is equals to 0, then y into e power x by y is equal to, first option c plus x, second option c plus x square, third option cx, and fourth option c minus x. Given equation is 1 plus e power x by y into dx is equal to minus of e power x by y into 1 minus x by y into dy. This can be written as dx by dy is equal to minus of e power x by y into 1 minus x by y by 1 plus e power x by y. And this is also a homogeneous function. This can be written as dx by dy is equal to y power n into g of x by y here, which is in that form. Put x by y is equal to v, that implies x is equal to vy. Now differentiating with respect to y, dx by dy is equals to UV rule v into 1 dy by dy of y, 1 plus y into dv by dy. So dx by dy, instead of this dy by dx by dy, can write it as v plus y into dv by dy. So v plus y into dv by dy is equal to minus e power x by y is equal to v into 1 minus v whole divided by 1 plus e power v. So y into dv by dy is equals to minus e power v into 1 minus v by 1 plus e power v, and this v taking to right side, it is negative, minus v, that is equal, you can multiply, LCM is 1 plus v e power v here, minus e power v, minus of minus plus v into e power v, here denominator 1, minus v into 1 plus e power v, that is equal minus e power v plus v into e power v minus v into e power v whole divided by 1 plus e power v plus v into e power v minus v into e power v will go, that is equals to minus of e power v plus v by 1 plus e power v, y into dv by dy, y into dv by dy. Now we have two variables separable, 1 plus e power v by v plus e power v into dv is equal to minus dy by y. Now integrating after separables, variable separable, integrating 1 plus e power v by v plus e power v into dv is equal to minus integral of dy by y. See, think about the left side function, numerator and denominator. Here denominator is f of v. F of v is equal to v plus e power v. Its derivative is v derivative 1 plus e power derivative e power v. So f dash of v by f of v into dv is log f of v. Log f of v, log f of v is equal to v plus e power v. V plus e power v is equal to minus log y plus log c. And taking log of v plus e power v plus log y is equal to log c. Log a plus log b, log of a into b. Log of a into b, v plus e power v into y is equal to log c. So v plus e power v into y is equal to c. Substitute v value here. V is equal to x by y. V is equal to x by y plus e power v value is x by y into y is equal to c. Now you can multiply x by y into y. X by y into y plus y into e power x by y is equal to c. Y will go. Y into e power x by y is equal to c minus x. But the given problem is then y into e power x by value is equal to y into e power x by y value is equal to c minus x. C minus x, which is our required solution. Fourth option is the solution of the given problem. Next problem, the solution of the differential equation dy by dx is equals to y by x plus phi of y by x by phi dash of y by x is first option x into phi of y by x is equal to k. Second option phi of y by x is equal to kx. And third option y into phi of y by x is equals to k. Fourth option phi into y of y by x is equal to ky. Solution dy by dx is equals to y by x plus phi of y by x by phi dash of y by x. The given equation in the form of y power x power n into y by x, put y by x is equal to v, y is equal to vx. Differentiating with respect to x, dy by dx is equal to v plus x into dv by dx. Substitute dy by dx is equal to v plus x into dv by dx is equal to v plus phi of v by phi dash of v. X into dv by dx is equal to v plus phi of v. This is v plus v will go. X into dv by dx is equal to phi of v by phi dash of v. Now variable separable, phi dash of v into dv by phi of v is equal to dx by x. Integrating on both sides, f dash of v by f of v into dv log f of v log f phi of v is equal to log x plus log k. Integral constant, that is log of kx, log a plus log b, log of phi of v. Therefore phi of v is equal to kx. Phi into substitute v value, v is equal to y by x. Phi of y by x is equal to kx, which is the solution of the given problem.